Hello class, today we are taking a look at solving some equations that have variables on both sides. And of course this is one of our topics that we need to be able to do pictorially or by drawing models, as well as our algebraic written work, and it's always a good idea to verify your answers. So let's start with our pictorial work here. We need to model the equation negative 2x minus 4 is equal to 5x plus 3. So let's start with our wall at our equal sign. We've got two negative x's, so two long, skinny, unshaded rectangles, since they're negative and they're variable tiles. Then we also have four negative constants, so four unshaded squares there for our four negative constants. On the other side of the wall, we've got our five positive x's, so five shaded in along skinny rectangles. And we also have our three positive constants, so our three shaded in squares. Okay, now the first thing that we need to do here is we need to collect our x's on one side of the equation, and we generally want to collect our x's so that they are positive. In this case, my larger coefficient is 5, that's larger than negative 2, so I'm going to choose to collect the x's on the right side, which means I need to cancel out the x's that are on the left side. So in this case, I've got my two negative x's on the left side, and we're going to have to add two positive x's to form zero pairs with those to cancel them out. Now obviously, to keep things fair, if we add two positive x's to the left side, we also have to draw in those two positive x's on the right side as well. And there we have that. In terms of our algebraic work, what we're doing is we're looking at our minus 2x on the left side. We're saying, what's the opposite of minus 2x? Well, it would be plus 2x. And of course, we need to do that to both sides of the equation. On the left side, our minus 2x and our plus 2x cancel out. We do still have our negative 4. On the other side, 5x's plus another 2x's is 7x's, and then we still have that constant of positive 3. Next thing we need to do is we need to isolate those x's. All of our x's are now on this right side of the equation, which is good. Keep in mind when these ones are crossed out, they no longer really exist. So we need to get rid of the constants that are on the same side of the equation as the x's. So that's these constants here on the right side with the x's. So what are we going to need to draw to cancel out three positive constants? Well, we're going to have to add three negative constants to form those zero pairs and cancel those out. As always, if I draw those three negative constants on the right side, I must also draw my three negative constants on the left side. In terms of my algebraic work, what I'm doing is I'm finding my x. I want to find what's being added or subtracted to that x. In this case, it's the plus 3. The opposite of adding 3 is subtracting 3, and as always, we'll do that to both sides. On the right side, my plus 3 and my minus 3 cancel out. I do still have my 7x's there. On the left side, negative 4 and getting more negative by 3 gives me negative 7. Of course, in my drawing, I do have 7 total negatives now on that left side. Last thing to do is to go ahead and split up my drawing into equal rows of 1x. So I can see that each of my x's in this drawing is just matching to one negative constant. So I can say my solution is that negative 1 is equal to x. In terms of my algebraic work, I want to undo the coefficient on the x. This 7 is currently being multiplied by the x, so the opposite of multiplying our 7 is dividing by 7, and of course we do that on both sides of the wall. Okay, our 7 divided by 7 gives us 1x, which is just x, and on the left side, negative 7 divided by 7 gives me negative 1. So obviously I get the same answer from both my pictorial work and my algebraic work. In terms of verifying, we want to substitute or replace the x in our equation with what we think our solution is. So we think that our solution here is x should be the number negative 1. So we're going to replace the x's on both sides of this equation with negative 1. We're going to leave everything else as it is. From here, we want to do our calculations on the left side and the right side separately, and we'll do those calculations in BEDMAS order. So let's start with the multiplication. Negative 2 times negative 1 makes positive 2. And that positive 2, take away our 4, gives me negative 2 as the value of the left side. On the right side, let's do our multiplication first. 5 times -1 is -5. -5 plus our 3 gives me -2. So the value of the right side is -2, the value of the left side is -2. Since the left side does in fact equal the right side, we know that our solution of x equals -1 is correct. It did in fact cause the left side to be the same as the right side, or be equal to the right side. The second question here, the only thing that's different is we do have our brackets on both sides. And we want to remember that the key to our brackets in our pictures is the idea of groups. So on the left side of the wall, we have 2 groups of tiles. And on the right side, we have 3 groups of tiles for our drawing. So let's start with that. Inside the brackets, I have 2 x's and our -4. So I'm going to go ahead and draw my 2 x's. And 4 negative constants. Now that's one group of 2x minus 4, but we need 2 groups. So let's draw ourselves a second group of 2 positive x's and 4 negative constants. So that's our 2 groups, group 1, group 2, of our 2 x's and 4 negative tiles. On the other side, we need 3 groups. Inside of each group, we need 2 positive constants and our 1 negative x. And then we need another 2 groups of that to make 3 groups in total. So we'll do another 2 positive constants, 1 negative x, and another 2 positive constants. Should have drawn these a little bit better. Let's do that. 2 positive constants and 1 negative x. Oops. So again, 1 group, 2 groups, 3 groups of my 2 positive constants and 1 negative x. Okay, from here, I want to go ahead and look at what that would be in terms of my algebraic work. I know I need to expand or distribute my coefficients into their respective brackets. So our 2 times our 2x would make 4 x's in total, and our 2 times our -4 makes negative or -8. On the other side, we'd have to do 3 times 2, which gives us 6, and 3 times -x is -3x. Remember, of course, this -x is really -1x. Okay, from here, I want to collect my x's. As always, I want to collect those on the side with the larger coefficient. So on the left side, I have coefficient 4. On the right side, I have coefficient -3. The left side is my larger coefficient, so that's the side I want to leave. Means I need to cancel the x's that are on the right side. So what cancels out my 3 negative x's over here? It's going to be 3 positive x's that I need to add in. Of course, if I add in 3 positive x's to the right side, I do need to add those 3 positive x's to the left side as well. And of course, we form our 0 pairs here. In terms of my algebraic work, I'm looking at my -3x on the right side, and I'm asking myself, what's the opposite of -3x? Well, it's going to be +3x. And of course, I have to do the same thing to both sides. On the right side, our -3x and +3x cancel out. Do you still have that constant of 6 still there? On the left side, our 4x's plus another 3x's gives us 7x's, and then we still have that constant of -8. Okay, next thing to do is to find the constants that are on the same side as our x's. So all of our x's are now here, and the constants that are with them are these ones. Those are the constants we're going to need to cancel out. So let's go ahead and draw in an additional 8 positives in total to cancel out these 8 negatives. And of course, if I add those 8 positives to the left side, I also have to add my 8 positives to the right side. Okay, in terms of my algebraic work, I'm looking at my x right here, and right now x is being subtracted by 8. The opposite of subtracting 8 is adding 8, so we'll do that to both sides. Minus 8 and plus 8 cancel out, leaving us with our 7x. And on the other side, 8 plus 6, or 6 plus 8, doesn't matter, gives me 14. To finish up, I want to split up my rows, so I'm going to go ahead and observe that each of my x's is matching to 2 positive constants, and so I can say that x is the value positive 2. In terms of my algebraic work, I'm going to do the opposite of multiplying x by 7, which is dividing by 7, and of course I'll do that to both sides. I'm left with just x on the left side, and on the right side, 14 divided by 7 gives me 2. Again, obviously, same answer between my drawing and my algebraic work. Let's finish up by verifying that solution. So again, we want to take the x in our original equation and replace just that with the value 2. And we're going to leave everything else the same. Okay, so now we're going to calculate our left side and our right side separately. So I guess it should be green there. We're going to start inside the brackets on the left side. So 2 times 2 is 4. 4 take away 4 is 0. And 2 times 0 is 0. On the other side, we'll start inside our brackets. So 2 take away 2 is 0. And 3 times 0 is 0. Since we did get the value 0 for the value of the left side as well as for the value of the right side, we can say indeed that our left side is equal to the right side, and therefore our solution must be correct. So I hope this has helped you with modeling, doing your algebraic work, and verifying your solutions to equations that have variables on both sides.